And I'm live. That is pretty cool. Today is 10th of April 2026, Friday. And before beginning, a quote from Meditations by Marcus Aurelius. Let's see. Okay, this one. This says, severely on shit. Severally, severely, severely on the occasion of everything that thou dost pause and ask thyself if death is a dreadful thing because it deprives thee of this. Okay, I will interpret it as, if you are doing something bad, ask yourself, is death really bad? Because if it comes, it will take you away from this. So that is just some suicidal thinking from Marcus Aurelius. And apart from Marcus Aurelius, today we want to look at some data. Let's see. I had no idea that there is this whole ecosystem. Just like in JavaScript front end, there is React, there is Next.js, then there is even WebAssembly and different stuffs. And not just React. React is just one part. There is also Vue.js and Svelte and all the other things you could be using. And on the back end also there are different things you could be using. And then if you do go in with React, then there are different libraries you could be using. There is a lot of stuff. And similarly, when you have made your backend and your front end and you have deployed it somewhere, then there is the part about looking at what is happening, how many requests are coming, and like looking at the logs. Yeah, I thought big professional people, they just SSH into their server and look at the logs, but no, that they are more smart than that. They have this thing called Grafana. There is a bunch of softwares which come together to make it easy for you to look at the visualization part of your backend. We use Prometheus, Grafana, Open Telemetry, Jaeger, Erin Jaeger. Cool. Let's see. I literally have like no idea what this is about, but we will take it from here and we will look at this. What is happening? Let's see. Welcome to logging and telemetry. This is the first chapter. That is the first chapter. Cool. Welcome to logging and telemetry. By now you have built a web service or seven maybe. You have added features, fixed bugs, and felt the thrill of seeing your code in action. Yep, I think we can say that. Not really, but okay. But sometimes things break. Yep, they do. Like mostly that is what is happening. Servers crash, users trigger weird edge cases, bugs sneak through. The difference between junior and senior developers isn't avoiding failure, it is building systems that handle and detect failure gracefully. In this course, you will answer two seemingly simple questions. How do I know when something is wrong? Okay, how do we know when something is wrong? In this whole course, these are the two questions that we are going to answer. Okay, and then how can I identify the problem as quickly as possible? Cool. Cool. So first of all, we have to know if something is wrong or not, and then figure out what the exact problem is. Okay, and learning goals would be understand observability and like, okay, which has a whole Wikipedia article on it. Observability is the measure of how well internal states of a system can be inferred from the knowledge of its external outputs. Okay, so if you know what a person is saying, then you know how he or she is feeling internally, kind of like that. What it is and how it can help you. Cool. Effective logging using Go's standard library package log. Okay, Go has a whole package on logging called log. Avoid common traps including missed logs, too many logs, and security leaks. Avoid common traps. Okay. Shade. This will tell us what is the effectiveness of logging. Because I thought, if like, why would you log? You would only log when you are in development to see how far, like logs in the sense of, okay, it is working, printf working this far, printf working this far 2, printf working this far 3. Like stuff like that for debugging, but you log in production also to see what is happening. Okay, so that is a cool thing to have, I guess, so that we can have this thing, this like effective tool with us on the new projects that we make from this point on. Cool. Set up actionable alerts without creating noise. Okay, alerts like maybe there are a lot of users or something which is supposed to work is not working, then you should get an alert or something. Collect and visualize metrics with Prometheus and Grafana. Okay, trace requests and diagnose performance with pprof, performance prof, pprof, and open telemetry. Okay, okay, cool. We do have Boot.dev CLI installed. Pretty cool. Run and submit. Yep. Yep. So yeah, for this course you have to have Boot.dev CLI installed. I do have it installed already, so this should just pass. Cool, it passes. Okay, so goals are clear because I have never taken anything on any course or even watched any videos about logging, so this would be a pretty cool experience. Throughout this course you will add logging and observability to Linko. Whatever Linko is a simple URL shortening service. Like link shorteners are common on the web. They let users take a long nasty looking URL full of parameters like this and shorten it into something like this. Cool. And I guess they do it by having a front end which looks like this, which is hosted at something which looks like this, and whenever you go there it just sends you a HTML which redirects you to the actual URL, something like this. Here's the catch: Linko has already been written for you. Your goal throughout this course would be to add observability to the service. Cool, we just have to have observability on Linko. Cool. Now what is the assignment? Clone this repository Linko. Okay, and then go into it and start the repository at localhost 8899. Git clone cd linko starter and go run shit go mod init to install any go mod tidy to install any dependencies if there is only one. Crypto, go run this. This should we don't see any log here, but I guess a server has started at localhost 8899. It has. Okay, we need to have ID password. Hello. There. Login. Unauthorized. Shit. Okay. Okay. But we have this installed. Pretty cool. And with Linko running, we have to submit this like cool. So we go to some other place and 3500 plus 350, 3850. Cool. This we have passed. And what is observability? A nice question, I guess. Observability is the ability to understand what a system is doing, usually with logs, metrics, and traces. With logs, metrics, and traces. Okay, they have their own definition, which they are explaining later on. With good observability in place, you can quickly tell whether a system is healthy and when it is not. Identify the cause so you can fix it. Okay, this is going to be handy. This is going to be cool. There are several primary tools that most professional teams use to achieve good observability in production. Okay, and I like this because when we are actually going to write new code, we'll at least try to keep these things in mind. Logs, event records. Logs, what are logs? Logs are event records from your system. Each log usually includes a timestamp, a severity, error, information, etc., and a message. Okay, that is the usual canonical format of a log: timestamp, severity, and a message. Metric, what is a metric? Aggregate measurements over time, like request count, error rate, etc., and latency and etc. Metric. aggregate measurements like average, median of different things. Okay, traces. Trace is a per request execution path, often across service, that show where time is spent and where failures happen. Okay, metrics are aggregates. What is the average time for something or stuff like that, average and median things. And traces is what happens in a single request, not in a bunch of requests at average, but in a single request. And then alerts, notifications sent when an important signal crosses a threshold. For example, an error rate spike. Okay, we will set all of this up, I guess. Add basic lifecycle logs. So Linko tells you when it starts and shutdowns. Okay, we have to add logs. When the server starts, print the following message to the console where D is the port number. Okay, we just have to print this message. We can stop Linko and cool. So for server, they are not using any library for starting a server. HTTP port flag.parse. Port list. Okay, we have this signal.notify. Okay. They are using some context things here. Signal.notify context. This is notify context returns a copy of the parent context that is marked done. It's okay. This thing takes a context that means something, context, and a list of signals, and then returns a context and stop call. Okay, stop function. And this returns a copy of the parent context that is marked done. It is its done channel is closed when one of the listed signals arrives. Okay, so that is like we take in a context, which is we can think of this as a structure. This function takes in a structure and a list of signals that we are looking for, and whenever one of these signals is actually there, whenever there is a interrupt or termination signal, this function signal notify context will update this ctx variable so that we can do whatever you want to do whenever there is an interruption or something like that. Hello, I'm doing amazing. How are you doing? Look at this data. And do you like the thumbnail? I made a like good thumbnail, I think, for this video. Clickbaity thumbnail. And here we have a Go server, which we are trying to visualize. Or before visualization, we are just trying to log this. Linko is running on server this. And ln.adder returns net adder interface to get the port from TCP listener. Type assert it to this first and then read port field. ln.adder. I don't get where are we running this. We are calling run here. Here we start a new server error, so s.start. And s is the server. Okay, and when we call s.start, our server starts, and we are calling this on a go routine. So after we are calling this on a go routine, after this we can just log printf this thing. Cool. And d ln. What do they mean by ln? Ln dot adder. I think s dot http server dot adder. We have http port. S dot http server dot adder. Okay, and this is a string. Okay, and I think instead of D here there is a string format in Go for any value type. Instead of D there is a string type which we can use for any type of value. Okay, let's go. It will be cool. I guess doctors are very good in Japan. Like, it will be pretty cool. And all the best. Next week, next Saturday or next Monday, depending on week or weekend. We can say we here, and let's see. Go run dot. That doesn't print shit. Okay, it does print something. Does start take something? Start does not take anything. Okay, we'll just print this and then we will say start. Cool. Why do we have 2 semicolons? That is not what we want. Cool. That should be cool, and I think we can say S here because this thing returns a string. Okay, that is what we wanted to print here when the server starts, and then print Linko is shutting down when the server is shutting down, which will do here at the end. CTX is a channel, a Go channel, and whenever CTX is not a Go channel, ctx.done is a Go channel, and whenever there is some value in this channel, only then we will go out. We will go after this line. This is like stop. This will stop the execution of this main thread at this particular line, and we will not go ahead of this line till there is some data in this channel, and this data would be put into this channel by this server, like, yep, by this http server. So we will be stuck here, and when we are one line after this point, that means the server was stopped. So we can just printf shutting down, and a new line would be very appreciated. Printf ln is not there. Okay, go run this, and Linko is shutting down. Cool. That is pretty good. The log said that since it was detected early, it is curable. That is pretty cool. That is pretty cool. If it was a little late, then there was very low chance. Okay, but this is cool. It is curable, and you found it early. So, like, that is very good news. And you are also solving lead code problems. So that should help you if you are able to solve it, but it can also like mentally disturb you. Lead code can be dangerous. Code forces can even be more dangerous, more depressing. So do it at your own risk. Cool. So we did this and this. Start your server and redirect its output to a temporary log file. Okay, this is some shell syntax. This is for piping. Whatever is the output for this thing, put it here. Okay, let's see this. Go run this. This will just run. I think put, this means put error into one. Okay, well, let's see what this means. What is this? Shell syntax. Ooh, this is an output redirection operation in shell to file descriptor for standard error. Okay, standard error redirect to another file descriptor. This file descriptor for standard out. Okay, okay, this means whatever, if there is an error, put that also in the standard output. Okay, and then there is a standard, and also there are three things: standard output, standard input, and standard error. Okay, 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 okay. So this means redirect whatever is the error into the normal output. Okay, okay, so this makes sense. And pass all of that in this sh command is something. Compliant. Sh is a POSIX compliant command interpreter. It is implemented by re-exciting, re-accessing, shit, exe, that is a new word, as either bash1 or -1 or zsh. Okay, so whatever is the shell, use the shell, because we do not know whether the user is using bash, zsh, or maybe fish. Fish, I think, is a shell or a terminal. It is a shell. Yeah, someone might be using fish. C, what is the C tag in this? SERNU. Let's go. Here, string. If C option is present, then commands are read from string. Okay, if there are arguments after the string, they are assigned to the positional parameters, starting with this. Okay, so this is the name of the default shell which is running. C means whatever the string is, it is not a string, it is a thing that you must run. And we are calling this trap command with empty int, and then we are calling TWE, and this shit, TWE is a command. Yep, I know a little bit about T command. Duplicate standard input, copies the standard input to standard output, making a copy in 0 or more files. Yep, yep, yep. So what this command does is it takes this command, takes the input and puts it there. What is trap command? Okay, recently I'm facing frequent nosebleeds sometimes, probably because of the treatment. Okay, because chemotherapy. Shit, are you going through, if you are going through chemotherapy and you live in Japan, all of your head tattoos like the Yakuza would be exposed, and that would look kind of badass, you know, having tattoos on your head, your scalp. One question on one tab and chatting on your stream on the other. Shit. Split window. I hope you are using aerospace. If you are not, then shit, that is illegal. You should use aerospace for all this stuff like this. You can do this with aerospace, which is pretty cool. And yeah, like, thank you for thinking that the stream is worth it for opening on the side. And let's print this whole command there. see what this is. And yep, man, rap. Go run this, start the current server, yep, merge the error and the normal output into a single flow pipe, that whatever comes from the Go program as the error or the normal output to this thing. This means run a shell with the given string as a command. Yep, this thing is the command. This is the first command. Inside that shell ignores the int signal, interrupt signal, that is control C. This prevents the T process from being killed when you interrupt the Go program. It ensures the log file gets properly flushed closed, even if okay shit, wait, does it mean that whenever interrupt command is being passed through, exchange that with an empty string? Do not like just remove it from the pipeline so that the T command is not able to see the interruption command, because you want to store our file properly. Inside the shell ignores pretty cool. Okay, let's have an hello.js, and we will have int I let I equals 0 for let I equals 0, I smaller than 1, e 10 is big enough, and let's see equals 0 C++. We have a big program here, and also let's just console.log. We can even remove this. Okay, if we run this will run. If we do one hello.js, this will run. Okay, pass the output of this program, which would be 1 2 3 4 5 6 and everything. Pass this to the shell. We are using ZSH, so instead of SH we can just say ZSH. It would work. C, take the input from the string, which is trap. Let's do this with trap and then without trap. The command that we want to run on bash is t log.txt. Shit. Okay, shit, this does not stop. Okay, I messed up. Shit, it is using 100% of the CPU. Shit. We can kill this. Shit, let's kill. Cool. Shit. Okay, we have to pass this thing as a string with the C tag. Shit. This does not stop on control C. Too much power. Okay, why is Ghost? Okay, Ghost is also taking a lot of stuff now because Ghost is printing all that. Do we have log. We do have log.txt, which is, and this didn't store properly. Log.txt wasn't stored properly. Okay. We need interruption. We have just removed this much and pressing Ctrl C, press Ctrl C, trigger, shutdown. This should be working for this command. And make sure both messages appear in this. Start the server again. There will be lessons including this one where the CLI test tests intentionally trigger the Linko server to shut down. In that case, remember to restart it between running and submitting the tests. Okay. Wait, hello. I'm going through chemo, yep, and it feels like my body burning when I'm okay, because they are literally putting radiation on you. Previously, my treatment was going in US, by I wanted to spend time in Japan, so my dad, yep, the doc gave me a doc address in Japan, and the doctor is connected with him, which is great. Okay, that is great. You wanted to spend time in Japan, you are in Japan with a nice, cool doctor. That is pretty cool. And also, I mean, I'm right now reading a book called Cancer Ward by Alexander Solzhenitsyn, and this book is pretty good. I have gone halfway through, and book is very good. Like, they also talk about chemotherapy, but back then they didn't know whether it helps or not. They were just thinking maybe this might help, and they were treating people with chemotherapy, and it was helping them. So pretty good. Chemotherapy is cool. You will become legit Walter White. Okay. And here, the yes, there is a problem here, and the problem is this part in our command. This in our pipeline is the thing that is taking time. This is the blocking process, and this is giving output to this. And here, this T command, let's do a little bit of maybe research kind of thing on T command, whatever T does. Okay, if we have echo hello and we pass it onto T and say log.txt, this T command takes in input from this and gives, first of all, stores it into this file and also gives this out as the output. That is why we see hello here, and we should see at log.txt hello. So this hello, which was given to this T command as an input, was stored in this file and also went forward. So this is like having a legit T if we are talking in terms of plumbing. When we have like data flowing in one direction, you put the T command somewhere, and this T command stores whatever data was flowing in a file, in a log file, and also this does not stop the flow, and this data is stored in the file and also keeps moving forward. So yeah, so like a snapshot in the middle of how was data looking at this point. That is cool. So go run dot, this will not go, one hello dot js, this will print or give out a lot of data. We will put that data through T command into log.txt. And if we stop, control C should be stopping this, but control C does not stop this somehow. Shit, control S stops the process. That is crazy. Shit. Control S legit stopped. By stop, I mean literally stopped it, and not kill it, but stop it. I guess I closed Ghost itself. Crazy. And what is this? 1450, 1540 minus 154, 1440 minus 54, 1386. Shit. Linko starter. If we just do one hello.js, why? Okay, it is stopping on interruption. That is cool. And this is stopping on interruption. Maybe the problem is this part, interruption. Maybe the problem is interruption. One hello.js run a zsh command from this string, and this string is this wrap int t log.txt, and control C works, and cat log.txt works. Okay, cool. So why were we not able to stop this program with interrupt? Let's see. Yo, hello. Shit, during the treatment it weakens the body because your cells are facing immense danger or something. Yo, wrecked. You are actually wrecked. Shit, I've seen this paperclip with eyes thing before somewhere. It was nice talking. You eat something, take some rest, and solve problems. That would be cool. Bye. Okay. So we had command 1, which was long running, and we piped it into T with file name.txt. Now, when doing this, control C was not working. Why was control C not working with this exact problem, which is solved by this? Okay, why control C does not work with T? When you pass control C, the terminal sends sig int to the entire foreground process group, meaning both the command 1 and E get the signal simultaneously. The race condition, there is a race condition. Command 1 stops and closes its end of the pipe. T also gets this signal and may die before flushing out result truncated or incomplete file logs. Also, in some cases, T catches this and exits first, which causes the pipe to break. Okay, but our problem was not they were breaking out of order. Our problem was they were not breaking at all. My keys pipeline didn't stop, it kept working with the correct spelling of working. Yep, that is what you call opposite. Control C sends sig int to the process group. T ignores it. No, we were not sending this before, but Go runs also ignores or catches sig int internally. Go programs often handle okay, there was something wrong with this, but okay, let's start the Go server now. Go run dot and to this one. This would mean the file descriptor for standard error is to put errors also in the file descriptor, which has the value 1, which represents standard output. So if there are errors, put them also in the standard output and push it through this pipeline, this like dash, this building thing. Push this onto the next thing, which is our ZSH shell, and C tag means whatever is the inside this string after this is going to be the command which you must run, and the command is trap int. That is, whenever there is a interrupt signal, exchange that with nothing, like put nothing, and that is going to be the first command. And the second one is T, put this whole thing into log.txt. Cool, server is running. Cool, server is running. We have done this. Control C to stop the server. we would see everything in linko.out.log. Yeah, I guess we should use the file name that they have given us. Let's see, but yep, everything was saved in this. The only problem was the file name linko.out.log. Cool. Start the server again before running the CLI test. Stop this. Start the server again. Go with this command exactly, and what would be the answer for this? 41 into 82. Uh, 3,200. Yep. 3,200 plus 82. Like shit. Yes, that is easy. 3,200 into 80. 3,282 plus 82. 3,364. 62. Okay, and to submit this, we just copy this, paste. This should hopefully work. Cool. Again, cool. And on to the next part. Which is this logging in Go. In Go, there is a log package, like legit a log package, which is crazy. The Go standard library has a built-in log package that we can use to produce messages with timestamps and other metadata. For example, this instead of this non-log message, we print this, which by default adds the timestamp, which has the date and the time. Cool. We can use log. Okay, you might think, why do we need a whole log package, a whole package for that? Can we just use this with the timestamp? And yes, you can, but there are some really great things about using a log package. For example, what do we get with this log package? You can easily change where the logs go. Okay, either to standard error or to a third-party service. Timestamps by default, functionality and other metadata management is built in. Okay, fatal errors can automatically exit the program. Example, log.fatal. We can use this log package to exit from the program. Okay, most loggers provide fine-grained control over which logs to emit with log levels like this, whether this is a log about information debugging or an error log. Cool. And then avoid printf, println, and related functions for logging in services. They are good for doing normal standard output stuff in CLI tools, but they are not purpose built for logging. Okay, that's some good advice. I think we will be using that. Okay, and admittedly the base log package in Go is pretty bare bones, but don't worry, we will cover the more advanced shade log/slog in later chapter. Okay, what is syslog? System logs. There is also a syslog package which is meant to send logs to the syslog server, but I would advise against that in almost all cases. It is considered a bit WART. What is this word? Okay, that does not look good.
What's a banana?
What we call this what even by Go team. Okay, so we should not use this because we will get skin allergies. If you are targeting syslogs, you are probably better off just using syslog adapter for slog. Okay, there is the base log package which we can use, then there is the slog package, and then there is syslog package, but we should not use syslog because it will give us skin infection literally. We should use slog instead. Okay, And what are the assignment for this? Assignment is switch Linko's apps log from fmt to log. Okay. In the main auth.go and server.go handlers.go, there are 4 files in our Go program. Replace fmt based logging with log. Okay. printf standard error with log printf. Omit this when using printf or slog. Both are automatically appended to the new line. Okay, so now we have to do some stuff. I guess let me just use tmux. Tmux is much better, but we still have to solve this and this. So 20 into 19 would be 1800. 1800 minus 40, 1760 minus 88. 1700 minus 80 minus 28, 1632. Probably 72. Shit, yes, 72, of course. Shit, 72. And 47, 50 into 74, 3500 plus 200, 3700. 3700 minus 3007. I'm struggling. 3700 minus 47 is 210 plus 12, 222, 500, 3400. Okay, shit. Okay, that was right. I was not very confident about that, but okay. Cool. Is the phone charging? Nope. Nope. Cool. So we have to change the way that we are logging all the places that we have used fmt at log dot error fatal flaw. Nope, 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 nope. Printf. Yep, let's use printf. This is the thing that you want to print, and where do we want to print this? We want to print this and oh shit. How do we output to error? Okay, there is no error thing here. Log printf. Okay, we will just log, I guess. Log printf this, and the error is not right somehow. No value use as value. The error is destination this, no value used as value. Too many values. Okay, the phone is just not charging somehow. I guess the error is because we are returning this. Or we can do fatal. because this is error. Yep. Remove this. Okay. Auth.go. Where are we using FMT? We are using FMT here, and this is not error. We have to include log. Cool. Auth done, destination done. Go.sum. Handlers.go fmt. Where else here? Log dot. We have to include log in here. Cool. Is printf is the error. Okay, we are not logging this. Okay, so fmt is good here. Fmt is good here. Cool. Fmt is fine here. Hello.js, no, we don't need that. May not go. Fmt. Where is fmt being used? Fatal include log. Cool, we don't even have to return. Yep. Fatal F. Cool. Fatal F. Log. Here also log. Fatal F. 3. Okay. Fatal F. And cool. Now we should be like pretty cool. We have changed all the things here. Go run this. Okay, that is good. We are seeing the logs with the timestamp. Cool. Let's just go run this. Put all the errors also in the standard output. Pipe it to zsh command, which is a string, and the command is first trace trap with nothing, the interruption command, and put a t there and put everything in log shortener linko.out.log. Cool. And cool, we do see everything here, and if we stop this and cat linko.out.log, we do see everything is being logged here. Cool. And what we have to do then? Run and submit the CLI test. Cool. Let's test this. This should work, hopefully. And not quite. Shit, we messed up something. Expected this, but got not this. Okay, this was expected, but this is what we got. running cat the file expected contained all of this, and it did contain all this. Linko is running, and then Linko is shutting down. This was there, but why did this test fail? Does not make any sense. Maybe some other test failed. Standard output was. Do we have to do something else also with this? Start this, and yep, replace everything. Replace fmtln with log println. Maybe the error is okay. Should we have to start the server? Yep, we have to run this thing while the server is running. Wait, server stopped. Yep. Now cool shit. Okay, we got error because the server was not running, and we have to do this while the server is running. Cool. And now it is running. Okay, and then use a logger. When will Grafana come out? I want to look at Grafana. We are at logging. When will Grafana and like that crazy stuff come? So log.printf seems to work well, but there is a better way. Okay, a logger is an instance. A logger is an instance of log.logger, which is a class, which is a structure, because we do not have classes in Go. We have structures that can be used to produce logs. Okay, generally it is better to use a logger object than the log packages functions directly for a few reasons. Okay, generally it is better to use a logger object. Okay, why? Not okay, they are also calling it object even though it is a structure. Strictly speaking, you can easily change where the logs go all in one place. Okay, you can add prefixes to the logs all in one place, and the final error is also, and the final benefit is also all in one place kind of benefit. You can change where the logs go at runtime. Cool. Using standard error, it is usually best to send logs to standard error instead of standard outputs. Okay, because standard output is typically used for the main output of a program, and we don't want to gum that up with logs meant for developers. Okay, makes sense. We should, instead of putting all the logs to standard output, we should put the logs to standard error. Okay. And when you create a new logger with this log.new, you can specify the output destination and OS standard error, usually the right choice. Okay, so then we create a log object to which we tell where we want the error, where we want the log to go. We want the log to go to standard error. This is the prefix. Okay, I guess this is the prefix. You can look at the syntax. Main.go, let's see, log.new. What is the syntax? IO, like where, then the prefix and flag. What is flag? Creates new logger. The output variable sets the destination to which the data will be written. The prefix appears at the beginning of each generated log line or after the header, if this thing is this. And then flag is provided. The flag argument defines the logging properties. The logging properties, LSD, acid logs. And then use a logger instead of log. Okay. Standard error is the standard error output, os.standard error. stream. Okay, and then the second argument is the prefix that we want. Here we are using message. Okay, message colon space. And the third argument is the log files, which can include things like time flags, which is used for telling what are the things that we want. And this thing includes the date and time flag. Okay. Then enforcing loggers. If you find yourself forgetting to use a logger, the golang linter comes with sublinter called forbid IGO that can be configured to prohibit the use of these functions. Okay, so we can tell our linter that we would never use fmt to print something, or we would never use a simple log to print something. Cool. And we can even tell our linter what the message should be if we do violate this pattern. And this is our regex. Starts with fmt, ends at this thing fmt, then a legit dot, and then print, and then a legit dot, and then anything. This is totally optional, of course, but it is nice to know. Yep, it is. And bro is from Cuba, but that is not a cigar, that is something else. Move from package level log calls to shared log instances. Okay, package level to shared level logs. That is crazy. Create a global logger in main.log. It should use OS standard error, have debug with a space as the prefix, and use the standard log. Okay. In the main file, we have to define logger equals log dot new os dot pt error. Prefix is debug space and log, not this, ls td flags. Cool. And var is unused. It will be used outside. And then in all the functions where we are printing something, logging something, update the calls to log.x. Okay. To use the global logger instead, start your server. Cool. Wherever you are using log, we should be using the logger instead. Substitute log with logger. That works amazingly. Here you don't even need to import log here anymore. Substitute log with logger, and cool, no error. Here remove the log import and substitute log with logger. Cool, no error. And enter.go. Substitute log with logger. Shade, except for this one. Here we do not want logger. Substitute log. Cool. And we did the change in main. Where is log? There is no log in this one. Cool. And then run the command. Go run this server. Pipe the error to standard output also, and then zsh from a string, and that is trap empty interruption, and t that thing into linko.out.log. That should work. That does work. We do see debug as the prefix, then timestamp because of the flag, and we do see this. If we remove this part, which is putting the error in the normal text that is visible, if we remove this part, we won't be seeing this log. and there is a proof by like literally removing this thing. Shit, okay, we do still see this. But okay, we do, even though we are seeing this here in terminal, which makes sense because we do see errors in terminal, but this should not be seen here, I guess, in Linko file.output. Or maybe we might see a residue from older files. Yep, but we don't see anything because all this that we were seeing here is part of error, and we are not putting error into our standard output, so we don't see anything in this linko.out file. But now that we are still not putting the error in there. Now we are putting the error in the normal output, and we should see something in linko.out, and we do see something in linko.out. Running the test. Yo. Cool. Pass. And then logging requests. Whenever there is a request on the server, this whole thing just seems like a bit too much. But yes, if you want your company or your software to be professional, you should be able to do all of, not just able to do, you should be doing all of these things. Logging. It is very common to log requests in web server. One of the cleaner ways to implement this is with middleware functions that logs the request after it is being served. Okay, I guess this is the industry practice to have a separate middleware which logs the request after your authentication middleware, or maybe before your authentication, or maybe different middlewares depending on if you were authenticated or not. But maybe you should not print every request. You should only print requests which were authenticated, because you might get a DDoS attack and you do not want to print every request that comes your way which is not authenticated, because that will clog the server, that will take up resources. Okay, we have a function that takes in a logger and returns a function which takes in an HTTP handler and returns that HTTP handler. And the function that we are returning from this request logger function takes in the HTTP handler and returns the HTTP handler, and the body of that function would be HTTP handler takes in a function, and the function that we are giving in to the HTTP handler takes in a request writer. And like this is equivalent to JavaScript rec and res in Express library. Request and response stuff, response writer, write the response and stuff about the request which came in. And in here we're calling next okay, which is just like out of random. And what is next? Okay, next is the name of the HTTP handler that this outer function will take in, that this function which is written by the outer function will take in as an input here. Next. Okay, and we are calling that next HTTP handler with this writer, request response writer and request data, and also logging after this. Wake up baby, a new s request to this a method to this URL just dropped. Okay, this one simply logs the request method, and the method and the path after the request has been served. After the request has been served, that is why this line comes after the serve. And the way that they are writing middlewares is crazy, like actually crazy. There is no abstraction, literally no abstraction over a middleware. Notice that you just have a wrapper around your actual request handling, and you are calling it to just assume that this is a middleware. Notice that it takes log.logger as an argument, allowing you to use any logger you want on a pre-handler basis. Before handling the request, we can give in the logger that we want to go with this particular request. So instead of declaring a handler that we want to log like this, that is next function, this thing, this, we can use the middleware API shorten and call the middleware function here, give it the logger that we want and the handler function. This thing returns a function which takes in the handler function for this. This is just crazy recursive stuff, kind of recursive wrapping. This is not a recursion, this is a wrapping a function around another function. Alternatively, we can wrap the entire mux multiplexer with the middleware so that all requests are logged. Handler would come from here. Assignment. Okay, we have assignment log each serve request with middleware. Okay. So we have to put a middleware around every request that we have in our Go server. Okay, let's do that. Okay, let's put a middleware around all the requests that we have. This seems very boring. Like logging is not fun. Okay. What do we have? That was crazy. Our main function is here, and okay, we call run in here. Run creates the server as new server, and new server is a function that we made called mux. This creates a new server. Okay, and these are the handlers. Okay, what do you want? You can use middleware. Assignment is implement a request logger middleware shown above and update its log output to use this format. Served request method and then path. So we want a prefix, no time or date or anything, and then method and path, where method is the HTTP method. Example is this. Then start the server and submit, and we'll see how it goes. So we need a different. Do we have a middleware file? No, we do not have a middleware file. We have a handler file. Good. We need a function which is like this. Middleware function. This function takes in the logger and returns a function that takes in a handler and returns the handler. Log middleware. This takes in logger, which is of type log.logger, and the return for this thing is a function that is a HTTP handler. Shit, that was quick. A function that is a HTTP handler and returns an HTTP handler. And here, cool. Time. No, we do not need time. Logger.printf, nope, undefined log, that is fine, we can fix that. Log.logger is not there. This log.printf, r.method, r is the request data, and that is all we need. Here the first thing is going to be the method, and the second is the path. And any errors? Yes, there are errors. We are not using this function, and we are not using logger. Here we are using logger here. Middleware passes log by value. Log.logger contains sync mutex. It is fine to pass this by value. No problem with this being passed as a value. Let's update our main logger here. Prefix should be this served request space, and we don't need anything. Log dot flag, what does this return? Int, or you can just say like 0, which means no flags at all. Cool. And we have our logger, we have a middleware which logs. We just have to put them together here. This is the function which should be called whenever we go to this place. Okay. Log middleware, call this with the logger. Cool, this thing returns a function. We will call that function with this. This thing returns a function which we are calling with this. Cannot use something like this. Should be working. We'll call the logger. HTTP handler function. Wow. Compiler cannot use log middleware this as function writer provider. Shit. Hello. Which language are you good at? Yes, C++, and where you are weakest among the weakest. C++. Though I have not built anything substantial or big in C++, I have majorly done whatever I have done, little things in JavaScript and TypeScript, and little bit of it. Okay, what are we doing in this log middleware function? Don't return anything. we do return something. HTTP handler function, convert this thing into a HTTP handler function, which calls next dot server HTTP. ipconfig get the handler function for this, which we pass on to the function which is returned by a request logger. But okay, log middleware logger. HTTP handler pointer to logger. Type of logger is logger.logger. Okay, and type of this logger is pointer. Say then we take shit, that was there. Shit. Logger, this thing is a pointer, so we had to change the input type of this thing from an actual logger to a pointer to a logger. Log. Middleware takes in this logger and we call it with http dot handler function for this and this shit. Di this, yep, it's http dot handler function, paste this, get the handle function for this, call it with this expected statement. HTTP dot handler function takes in handler index. Takes in, yep, return http dot handler function. No. Okay, this takes in the logger, which we call with this. Okay, missing comma. Why do we need comma? Shit. Okay, there are two types of things. This thing needs a handler function. So I guess we just pass this to a handler function. Shit, no. No. Yo, we are just figuring out how to add a middleware in Go server. It's not going very fine. And this thing needs a function that takes an HTTP writer request response a string and then a function called handler whose signature is this HTTP dot response writer and request, which is exactly the thing being returned by this thing returns a function that returns a handler, and then we are calling that internal function at place, which returns a handler, and the handler is this. Handler's definition matches. Shit, no. We do have to use HTTP. Hello, I know nothing about Golang. Okay, thank you for that, but Golang is not very complicated. Go, look at this number of keywords in Python. I guess 30 something. I don't know. 35. Okay, and number of keywords in Golang less than Python 25. So Golang is, you could say, simpler than Python, but the problem with Golang is that to add a simple thing, you do not have a direct function which you can expect to have in other languages. In Golang, you don't even have a while loop. You just have a for loop which runs infinitely. So yep, they are reserving keywords for some reason. They don't have much keywords. You have to do things, take longer, like more code to do. compared to C++. Verbose, my definition of verbose is that, hello, Gorgon Black, shit. Verbose, my definition of verbose is that when you look at something, that just means that specific thing. You cannot confuse that. And since you are writing more code in Go compared to other places, and also like simpler things in simpler terms, then I guess that is true. Cool. No, I don't even know what that is. OpenSense. An open source firewall that has been built in support for unbound DNS strict port forwarding geo. Okay, okay. For cutting edge network protection. Okay, so this has a GUI, I suppose. Yes, this does have a legit GUI. So this is like UFW in Linux. With GUI, maybe. UFW is uncomplicated firewall, a CLI tool which you can use to configure your firewall. Not quite shit. Okay, OpenSense and UFW are quite different tools. Even though both deal with firewalls, here is how they are compared. UFW, uncomplicated firewalls, a simple front end for IP tables on Linux, protects a single host server command line tool. Okay, we can even have GUFW, which is crazy. Then OpenSense, a full firewall router operating system based on, okay, it is a whole operating system based on FreeBSD, Berkeley software distribution, runs on dedicated hardware and sits between your router and the rest of your network. Okay, so M dash. Okay, shit, this response was probably written by AI. This has M dash. All traffic must pass through it before reaching other devices. Okay, this is an operating system which sits between your router and the devices, managed through a web-based interface, making it accessible. Okay, 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 okay. So how do you set this up? Like you have an old laptop and you connect it with to your router, and everything else is not connected to your Wi-Fi but to your old laptop. I suppose Boot.dev costs how much, and it is very good. Boot.dev is very good and it is free. Like, yep, Boot.dev is free. But like in all the lessons, in all the courses on Boot.dev, there are multiple chapters, right? And only the first few chapters you can submit these. You can submit your answer and check whether it is right or wrong. But then for later chapters, like let's go to a later chapter here, we are in guest mode. Even though we can access all the content, everything is here, we just cannot submit our answer. That is the only thing that you cannot do, but otherwise it is pretty cool. Dash shit. Okay, cool. Okay. Let's get back to logging, which I don't know, looks very boring, but that is just because I haven't had a real server. We actually did this. We did 2 of them. We are at this logging requests and trying to fit a middleware in the middle. Log middleware. Okay, the compiler is saying cannot use log middleware as the function that we want has to have a signature like this. Shit, but Joe Biden couldn't do a signature. He used a pen for this. So the function that we need here has to have a signature of this, where the first argument is going to be a thing we use for writing response, and second is a thing we use to get a structure we use to get the data about the request. But we are passing here this, our own custom function, which takes in the logger and takes in this, the value of interface type HTTP handler. And this function that we have written, this function returns another function which takes in another function and returns another function, layers, plot within plots. Log middleware logger, this thing is returning a function which is cool, and we are calling that function in place. Is nope. Now the problem is that we cannot just pass a random thing in here. We have to convert this, call this with handler function, either a class or this, a class handler index. Value of interface type handler, HTTP handler. Let's var hello equals okay, that type is HTTP handler. And the error is compiler cannot use this variable of interface type HTTP handler as this, but the interface for this thing is HTTP handler, type interface HTTP handler. Which is different. Shit. Okay. Okay. Okay, it works. Cool. So the problem was you have a normal function, you pass it to a function like this, HTTP handler function, which takes that normal function and converts it into a HTTP handler. And there are two calls to this mux function. You either provide that handler or you provide the function which will then be converted into a handler. So this log middleware, this whole call returns a handler function, not the bare minimum bare function, normal function. But you are trying to pass that handler function into a function that does not want the handler but the function. So cool. If we do this and then here we do convert this into an HTTP dot handler function. Cool. As written, HTTP dot handler function. Cool. And we just have to do log middle. Okay, we just have to put all these calls into wrap them around this thing. It's a log middleware logger function call. So either we manually do this, or since we are Vim, we are not users of Vim, we are Vim, literally Vim. So we will use some regex magic thing. I'll be honest, OpenSense is very steep as a way. Okay, VLANs are headaches. So what is VLANs? I swear, if I lose access to my managed switch one more time, shit. VLANs or something. Wait, VLANs in networking. I don't know shit about networking. Virtual local area network. Okay, I know LAN, local area network. Let's go. A logical segmentation of the physical network, allowing, this is similar to like virtual machines where you do not give the whole thing to something else, but the operating system which is running internally thinks that it has the real deal, but no, it does not have a life. Okay, yep, we are Vim users. We will use not a macro. Should, okay, yep, there are two ways. Either we use a regex for substitution, or we use a macro. Using a macro would be easy. Let's use a macro, and then we will use regex substitution command here. Q A to start recording a macro in register A. We will go at the start of the line, find the comma, go to the right, insert mode, log, middleware, this thing, open parentheses, logger, close parentheses, open parentheses, exit, go to the end, close parentheses, exit. Q to stop. But shit. We should also go to the next line at the end. Now if here I were to do percent, no, at the rate A, done. 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 Cool. That was easy using macros, but how do we do this using a substitute command? So let's see on this line, substitute regex, comma, there is going to be comma, then something, and then this. At the end of the line. Okay. Why is this not matching? That should be matching. And so okay, we can use some help here. Help regex regular expression. Cool. Okay, let's go through this. Pattern. Yep. We need pattern, magic, or no magic, very magic. Select groups and Vim regex. Yo, I will keep going. Thank you. Cool, like this. Okay, shade. The last bracket should be treated as a bracket. Cool, makes sense. Okay, and that the error is because magic or very magic. magic. Shit. Regex magic. Some characters in the pattern, such as letters, are taken literally. They match exactly the same character in the text when preceded with a backslash. However, they get special meaning. For example, A matches the character A, while backslash A matches any alphabet character. Okay. And this is the default behavior. Yep. If the character is taken literally or not depends on the magic option and the items in the pattern mentioned next. Okay, the magic option should always be set. When we mention the effect of no magic here for completeness, but we recommend against using that. Okay. Use of this makes the pattern after it interpreted as if magic is set, ignoring the actual value of the magic option. The magic option should be set by default is what they are saying. How do we set the magic option? We just say magic. Shit. Help magic goes here. Okay. On this line, substitute. Like we already did this using macros, but we will do this using web. Substitute comma. Shit. This has to have a special meaning. Nope, a special meaning. Okay, comma, and this alleged this at the end, and this special meaning. This should be at the end. Dollar. Where is dollar? Okay. On this whole thing, substitute very magically, comma, and then anything, and then closing bracket at the end. This has to have a special meaning. This has a special meaning. Reject have special meaning by default, and when rejects small v, substitute small v comma, okay, anything after this, and then a little this, okay, substitute this. No, this should be working. This is not working somehow. Shit. Okay. Let's use Claude for this. Hello, Dom DMK. What I'm trying to do here is we want like this whole thing to be wrapped around this call log middleware. We just put this text inside of this function call, and we can use this macro that I have for this, but I'm trying to use this and to do this same thing which we can do in like not even 1 minute, in like 5 seconds. I'm trying to do that same thing by spending 15 minutes on learning about regex. So yeah, that is what programmers do. Okay, in Vim, this is not selecting the whole text between a comma and this, and the thing that we are using is here in the whole file. This means the whole file. Substitute in very magic way, start is anything legit, this cool. This is not working. The issue is this with this matches 0 or more comma, which is probably not what you want. Okay, more likely you want a text between a comma and this, so you need to capture the const. Okay, shit, this thing. Okay, the problem was mine. We have to give that star thing the star special symbol, some symbol that we are looking for. Let's look for comma and then anything, any number of times till you see a legit back right. Cool. Okay, we are able to select everything. Till the end and substitute this whole thing with comma middleware logger http shit, not http $1 how to put selected pattern in the replacement text. I'll put it there. Yo. Okay. /1 not $. Because we also included the comma. Shit, yes, we also included the comma. We should not include the comma. Substitute. Okay, this is for real, final. We will get this finally now. This thing, and then any amount of thing anywhere. Till the end, substitute that with dot with comma. Yep, with comma log middleware logger this get thing number 1. Cool. Okay, regex, let's go. And hopefully this is going to print the things that we want. Go run this. Okay, let's test this. And shit, I guess that is okay. Okay. Yep, I guess that is okay. We do have middleware. Cool. We can just submit by pressing -s. And shit, we got wrong answer. Test fail. Which one? This one. Debug expected to contain debug. Okay. And the actual thing was debug. And okay, our formatter. Okay, why did we see this? That is not what we should be seeing. Debug. We have changed the signature. For this logger. Yep. Okay, shit, yes, we have to run this with the correct command. My bad. Yep. And go run here, put the error also in the normal output, and zsh run this command zsh from string trap nothing for the interruption comma t into linko.out.log. This has to be like -c. Okay, and now we should be okay. Shit, okay. If we have this, we have this debug is not there. We do not have debug here. Why don't we have debug here? Do they say something about debug? That we have to print debug somewhere? I guess we don't have to change the path. The method for this logger. Base, cool, and served request and everything should be changed here. Served request. Cool. Shit. Go run this without submitting. Okay, that should be cool. Not quite. Test field expected status code 200 but got 0 because the server is not running right now. It is running. Cool. And again we got error. Expected this but found this Linko server. Everything is okay. Except for this debug was not there. Debug is legit there. DEBUG debug. API stats. Okay, I don't get where does it want us to print the debug text. Alternatively, yep, we have successfully added the middleware. This is there. Debug is not there. We can manually add this. Seems like the right way to do it to pass the text. Okay. Server start and linking. Yep. This is illegal. Debug. Writing debug like this manually. Served request. Space. Cool. In the handler. Cool. Go run the server. Test. We saw shit. Debug should not be there like this. ERVED, RE. Wait, R has to be small. Was that the error? Wait, that R has to be small. Shit. It was looking for small r. We were printing capital R. That is an error. Anything else? No. Yes. This. I guess this was right. Debug and everything is here. REQUEST. Okay, cool. Finally, it is right. Yeah, perfect. Cool. And on to the next chapter, which I guess we will continue later because I'm just getting a bit overwhelmed and this is getting boring. Logging, seeing how to log. Yeah. So we will continue tomorrow and that would be good about logging. So today what did we saw? We just saw logging share. We didn't see anything interesting today. We just saw what is logging. Okay, they have a phone aspect ratio video here. Crazy. When will they introduce Grafana? That would be the nice thing. Okay, they are just fully into seeing all this, explaining all this log stuff. Cool. Okay, so that would be it for today. We saw logging, which is very boring, but okay, cool. And yep, thank you for being here. Bye.